Hey everybody, another video from me. This video is in relation to 2.7 calculus. In particular, we're focusing on all the achieved questions for the 2022 exam. If you're looking for more achieved questions like this, check out the link in the description. I think I've got all of the achieved questions from 2015 to present there. So that might be a good resource for your study. So let's get into the first, question 25. There's only 3 achieved questions in this exam, so you needed to make good progress in the merit stuff to pass. But we've been given a function here, and we've been asked to use calculus methods to find the gradient when x is equal to 3. So what that means is we need to find the gradient function through differentiation, and then we need to substitute in x equals 3. So let's do that first. So let's write down my original function. So fx is equal to 2x to the power of 4 plus 4x cubed minus 20x squared minus 5. And I normally rewrite the question myself because I find when I do that I tend to make less math errors because I'm not going back from the question to my answer, and that's kind of where math errors creep in sometimes. So f dash x, my derivative, is going to be equal to, don't forget it's my coefficient times my power, so 2 times 4 is equal to 8, and my power drops by 1, so that 4 is going to drop to 3. I'm going to repeat the same for the next part. 4 times 3 is 12. And my power drops by 1 to 2. Again, we've got 20 times 2. That's going to be 40, or minus 40 in this case, so minus 40. Power drops to 1, but that's an invisible 1, so I can ignore that. And that negative 5 differentiates to 0, so I can just kind of ignore that for my derivative. I'm now going to substitute in x equals 3, so f dash 3 is going to be equal to 8 times 3 cubed plus 12 times 3 squared minus 40 times 3. So a bit of a mess there, so messy cubes, all that sort of stuff. So what I did was I plugged that straight into my calculator to avoid doing a dumb error, and when I did that my gradient was 204. So that's a pretty steep line, right? So that means it goes across 1 and then up 204 at that particular point, so that's a huge gradient. So we're now on to question number 26, and question 26 is a bit different. Normally achieved questions focus on differentiation, but this one here's an integration question. And that's because they've given us the gradient function. We can see f dash x there circled, so we're asked to go back to find fx, so we are integrating. So let's start by writing down the question. So we've got f dash x is equal to 4 minus 6x plus 2x squared. Now going to differentiate or integrate to get fx. Oh gosh, terrible handwriting there. Fx. So 4 is going to become 4x. When we integrate, the coefficient is divided by whatever the power is plus 1. So that's going to be 6 over 1 plus 1. Noting 1 is the original power, and then we always add 1 to it. And then we're going to repeat the same for the next part. That's going to be, oh gosh, I should write x to the power of 1 plus 1 as well. And then we're going to go plus 2 divided by 2 plus 1, x to the power of 2 plus 1. And then we've got plus c at the end there. I can now simplify that a bit more. So 4x minus 3x squared. That's because 6 divided by 2 is the 3 there. And then we've got a fraction there, plus 2 over 3 x cubed, and then we've got plus c. So I've got my integration there. However, it's not the full function because I've got that constant. So I'm now going to need to substitute in some x and y values to figure this out. So for this part here, it's probably best to say that y is equal to all of this to do with x. And from my coordinate, I can pull out that x is equal to 3 and y is equal to 4. So I'm going to substitute them into this expression here. I'm going to take away the y's, put in 4. I'm going to take away the x's, put in 3. So that y there, that's going to become 4 is equal to, so that's going to be 4 times 3, noting the x is gone, the 3 is in, minus 3 times 3 squared plus 2 over 3 times 3 cubed plus c. And you notice all of these here, that's just a number. So we need to go ahead and evaluate that number. I did it kind of piece by piece here. I was a bit worried if I did it in the calculator I'd stuff it up because there's a lot of messy stuff here, so it's probably easier to do this one by hand. So that means 4 is going to be equal to 3 times 4 is 12. 3 squared is 9 times 3 is 27, so it's going to be minus 27. And then we've got 3 squared is 27 divided by 3 is 9 times 2 is 18. So that's going to be plus 18. And then we've got our plus c. Simplifying all of this here, 12 plus 18 is 30, minus 27 is 3. So that means 4 is going to be equal to 3 plus c. And then this here is a nice easy step, just minus 3 to both sides. 1 is equal to c. Therefore, my final equation, fx, was equal to, it's this line up here, but I've now got the plus c value to add back. So it's going to be 4x minus 3x squared plus 2 over 3x cubed. And then finally, plus 1. That is the number I just calculated. Question number 27, the final achieved question. This one was a bit out of left field when it came up. It's nothing like this has really been in the exams before. But basically, we've got the original functions up here, and we've been asked to sketch the gradient function for each of them below. So that basically means we need to differentiate. So the way I did this one, just through my graph skills, I knew that this line here was y equals negative x. Because you can see, for example, down here, you got 2 and negative 2. So we can see that negative relationship appear. So when I differentiate this, y dash would be equal to negative 1. So what I've got here is I've got a horizontal line doing that. So negative 1, this one's a bit weird. So that there is negative 2 there. So negative 1 would be kind of up there. We've done that dot, that little dot. And if I draw a horizontal line that way there, that's my negative 1 value. So same thing for the second graph. This graph again is just a simple one, y equals x. When I differentiate that, I get y dash equals to 1. So it's going to be similar to this, except it's going through positive 1, which is over there. So again, sketching that line there. That's my gradient function there. And the last one, this one's a parabola. And the trick with parabolas is if you can roughly find out the equation of the parabola using your graph skills, you can just differentiate that again. So the thing I always look out for is the coefficient. If it goes across one, up one, like this one does here, we know there's no coefficient. And this one here, there's no horizontal or vertical movement. So simply the equation here is y is equal to x squared. So that's like your bread and butter parabola, probably learned in year 9 or year 10. Differentiating this, y dash becomes 2x. And that's my equation there. So my 2x is going to come through the origin there, and it's going to go across 2 and then up 2. So something like that. So it's going to look like a line going like that. So it's a fairly steep line across 2, gradient of 2, but also going through the origin. So that wraps up all of these achieved videos. Hopefully you find them useful. Again, check out the link in the comments if you're wanting to find more achieved questions like this to practice.